Welcome to today's lesson, Volume of Solid. Many students will face this wire question where you are asked to find the capacity in liters of a bucket 24 centimeter in diameter at the bottom, 16 centimeter in diameter at the top, and 18 centimeter deep. But we know that the shape of a bucket is not a regular shape. So what will be the first thing you do in solving a question like this? Well, we're going to construct the bucket and put the dimensions. Let's do that now. Now you have the bucket on your screen. But before I explain the bucket shape you have there, remember to like, share, and subscribe to this YouTube channel. If there's any question, use the comment section. If there's a topic you want me to teach, put it there. I want to hear your feedback from all the videos I've been making. Now let's get back to the video. Let's solve the question now. This is the bucket. Remember, the diameter at the top of the bucket is 24. And we had to take the radius. The radius, if the diameter is 24 centimeter, and the radius will be 12 centimeter. At the bottom, the diameter is 16 centimeter. And if the diameter is 16 centimeter, then the radius will be 8 centimeter because radius is half of a diameter. And then we are told that it is 18 centimeter deep. So that's the height. You can see it there, 18 centimeter deep. As we know, there is no formula for solving for the volume of a bucket. So what we're going to do is to construct this bucket into a cone because we have the formula for solving for the volume of a cone. So that's what I'm going to do now. So let's construct. Now you can see the construction now. It has become a cone. So it's as if you have two cones here. You have the bigger cone and then you have the smaller cone. Now this is quite easy to solve because the volume for solving a cone is 1/3 pi radius square height. This is the formula that will guide us in solving the question. But before we do that, we have to get the dimensions. We've constructed an additional figure where we have x. From this bottom of the bucket to the edge of the cone here is x. So we had to look for x. So what do? We use the principle of similar triangles. If you remember the principle of similar triangles, I'm going to apply it here. Just watch what I'm going to do. It's going to be a guiding principle. Like I said, there are two cones here. This is the smaller cone, and this is the bigger cone. So I'm going to, because they are similar, express it this way. 8 divide x. The 8 here is the radius of the bottom of the bucket, and the x is this. So this one is for the smaller cone. And let's go to the bigger cone. It will be equal to, the bigger cone, the radius is 12, which is similar to this here, 8. And then remember, for the smaller cone, this is the height, but the bigger cone, this is the height. So the height is 18 plus x. So what do you do next? You cross multiply. 8 multiply 18 plus x equal to 12x. So let's expand this bracket. 8 multiply 18 will give you 144. 8 multiply x, that will be plus 8x, equals to 12x. What's the next step? Collect like terms. So it becomes 144. 8x will move to your right hand side. So that becomes 12x minus 8x. And this will give you 4x. 144. You divide both sides by the coefficient of x so as to get a value for x. So therefore, your x value is 36. Now with this, we can now solve for the volume of the buckets. Using the formula, Volume of buckets equal to volume of bigger cone minus volume of smaller cone. So this is bigger. Now remember the formula for solving for volume of the cone is 1/3 pi radius square height. So for the bigger cone, it's going to be 1/3 multiply pi, and pi is 22/7 in this case. And multiply the radius of the bigger cone. So the radius is 12. So 12 square is 12 multiply 12. And multiply the height. The height is this, which is 18 plus x. So 18 plus x, let's get a height somewhere here. 18 plus x, and x is 36, will give you 54. So that's 54. So we've gotten the dimension for the bigger cone. Minus 1/3. Now this time we're going around to the volume of the smaller cone. 22 divided 7. Multiply the radius of the smaller cone. Now this is the radius of the smaller cone, which is 8. Multiply 8. Multiply the height, which is x, and x is 36. So if you solve this, volume will be, use your calculator. This is easy peasy, so I'm not going to go into this. When you multiply through, you're going to get 8,146.29 minus this minus. Then when you also multiply through, you're going to get 2,413.71, all in cube, centimeter cube. Centimeter cube because it's volume. And if you subtract this 8,146.29 minus 2,413.71 is going to give you 5,732.58 centimeter cube. Now recall the question says, find the capacity in liters. So you're going to convert this to liter. And in converting from centimeter cube to liter, you divide by 1,000. And if you divide this by 1,000, you're going to have 5.73 to 2 decimal places at your answer to the question. I guess this will not be a problem for you anymore if you're asked to find the capacity of a bucket. Please take your time to study through this work. Remember the formula for solving for volume, it's going to be a guide. In questions like this, you always need to construct. That's where you can easily understand how to find solution to the question. Now, please tell me how you feel about this video. Put your comments in the comment section. If there's a topic you want me to teach, put it there. And please remember to subscribe to this YouTube channel. Like and share the video. See you in the next video.